Hi everyone! We've already covered several shaders that simulate fog, but they were mostly side effects of technologies that aren't primarily designed for fog. This time, we'll finally create a true fog shader and take a look at what options Godot 4 offers for this type of effect. If it seems to you that the Godot editor in this video looks a bit different, it's because the full version of Godot 4.6 was released a few days ago, and I've already upgraded to it. It looks impressive, and I'd say it's also more compact, so more fits to on the screen, and the work could be more convenient. But let's get back to the shader we want to create. And once again, I'll start by creating a new scene, which this time will be a 3D scene, because volumetric fog is also a 3D object. So let's right click on the scenes folder, create new scene and switch to 3D scene, and let's call it vfog. Okay, that should be okay. And if we would like to add fog to a 3D scene, we have two options. The first would be to enable volumetric fog in the world environment node and set the appropriate parameters. However, such fog would be rendered across the entire scene, and we wouldn't have any way to influence its shape. Therefore, a special node called fog volume is more suitable, as it allows us to isolate the fog into a box, a sphere, or other basic shapes. So I'll add this node to the scene. Okay, so right-clicking the root node, add child node, and let's find fog volume. Here it is, create. Okay, and we can immediately see that Godot isn't happy about something. According to the message in the tooltip, it looks like, even in this case, we need to add a world environment and enable global volumetric fog. So let's do it. Right-clicking, add child node, world environment, and in the inspector, let's create a new environment here. Click it. And here it is, volumetric fog. Let's click on, and it's enabled. Okay, so now we can see that what such a global fog looks like. But the warning icon is still there and hasn't disappeared. I'm not entirely sure why that is, but I found that simply performing a reload save scene resolves the issues. So let's open a scene, reload saved. Saving it first, and now scene, reload save scene, and it's gone. So this applies to Godot editor in version 4.6 and before, and it's possible that this minor bug will be fixed in future versions. Let's return to the fog volume. In the inspector, we can see that it's set by default to a box local, with dimensions of 2 by 2 by 2 meters, which we can leave as is for now. However, we don't see anything in the 3D editor because this object doesn't have a material assigned. And as you can probably guess, we'll apply our shader to that material. So I'll create a new shader material. Here it is, creating new shader material. Click on it, and let's add a new shader, which is, as we can see, of the mode fog. All right, and it's called vfoggd shader, and as usual, I'll put it to the shaders folder. Create, and click again to open it in the shader editor. So, as we can see, Godot has created the skeleton of a fog shader based on a template. Such a shader has a single method called fog, which Godot will call for each voxel, that is, a fog element, as this comment explains. It also mentions an axis-aligned bounding box, where it is right here. And if we don't see it, it means that our gizmos are turned off. Let's check it in perspective. Yeah, view gizmos. And now we can see the box. But of course, it might get in the way a bit. So let's just disable it again. And also the arrows, I mean the transition gizmo. Okay. And now let's start writing the shader. The main difference between a fog shader and the shaders we used in earlier tutorials is that a fog shader isn't applied to a canvas item or a mesh, so there are no UV coordinates available. Instead, Godot provides us with an internal variable called world position, which is a vector3 containing the position of the current voxel. So I'll delete these comments and write our first line, which would be vec3 p for point equals world position. Okay, as for the output of this fog method, we'll have three variables available that we will be setting: density, albedo, and emission. We know albedo and emission from spatial shaders, and they have the same meaning in a fog shader as well. So let's try setting albedo to a red color. Albedo equals vector3, 1 red, 0 green, and 0 blue. Okay, and we still don't see anything. How is that possible? Fog isn't a continuous surface that light could reflect off. We need to define the density of the particles the fog is made of, and this density is set to 0 by default. So we'll add a line setting the density variable, and for now let's assign it to a value of 1. Density equals 1. Okay, and now something finally appears. Let's zoom in. We have basic red fog, and if I move the camera closer and rotate it, we can see that the fog is indeed confined inside the box within the specified dimensions. Okay, but for a real scene, we need a camera, so let's add one. Right-click in the root node again and camera 3D. Okay, and now we can see something in the camera preview. And we'll also want a light source. There is one in the editor, but if we were to run the scene, we wouldn't see anything. So let's add a directional light to the scene. A child node, directional light 3D. Okay, and let's keep it as it is for now. But the color is quite dull, I guess, because the red fog is blending with the global gray fog, so the light is being heavily absorbed by its surroundings. Let's try brightening the fog a bit so that it emits red light on its own. Let's add emission. Equals the same color, vec3, 1, 0, 0. Okay, that's much more visible. And if we wanted to hide the global fog, let's set the light source to ignore it. So I'll selecting directional light 3D, and here in the light section, let's set volumetric fog energy to 0. That's nice. Now we have a solid base for improving our shader. At the beginning of the video, we saw the effect of moving fog with certain irregularities, so we'll need functions for generating pseudorandom numbers. We've used such functions many times before, so to save time, I'll just copy them from one of the previous shaders. So let's open this window and paste the mentioned functions. And here they are. This algorithm, this one, is reminiscent of so-called Perlin noise, with smooth transitions around the edges, which is achieved by interpolating using the mix functions. Such a function is usually sufficient, this one, if we want to create something like static chaos, but for a fog effect it needs a bit more refinement. So I'll add a third function in which we implement fractal Brownian motion, or FBM for short. This won't be new for those who have followed our tutorials before, but for everyone else, or if anything is unclear, I recommend reading the relevant chapter in the book of shaders, which I've linked in the video description. So how will it work? Simply put, we'll get the value of the noise function over 4 iterations with different coefficients, and we'll apply a rotation matrix to each to achieve some turbulence. The function will look like this. Let's write it here. Float fbm with the parameter vector 2p for the point in 2 dimensions. And now the rotation matrix first. Mat2, let's call it M, is mat2 and consists of 2 vectors, 2, 1.6, 1.2, sorry, 1.2, and another vector 2, negative 1.2, 1.6. You may remember for previous tutorials that we usually use cosines and sines of some angle. So this is just a result of the predefined angle to keep it shorter. And let's create the accumulator for the fractal Brownian motion. It would be called f and starts at 0. And now f is increased by 0.5 times the result of the noise function applied on the p, and let's increase, let's put it on the same line so it looks like more readable, because now we will do the same for 3 other steps but with different coefficients. 0.25, 125 is always the half of the previous value, 0.625, 0 I said. Okay, and the noise p is the same, and the multiplication again, but it's not necessary at the last step. And finally, let's return the result, which is a bit modified to fit in the desired range. Okay, that's it. This is just one of many possibilities, so feel free to experiment with these coefficients used or convert them into uniform parameters. Speaking of which, we'll need uniform parameters in any case to be able to tweak or control our fog from a script. So now is probably a good time to add them at the beginning of the shader. Let's start with the color. So I'll move to the start of the script, and now uniform vec3 fog color with a hint source color for the tooltip in the inspector, and I mean the color picker in the inspector, and the default value 0.2, 0.8, 0.4. Okay, I set the default value to a shade of green, which could simulate the hero in our game passing through some toxic environment. Next are 2 parameters we'll use to control the internal structure of the fog. So uniform float density scale with a hint range, and the initial value let's set to 1. And the range would be from 0 to 10 with the step point 0.1. And the second one, uniform float noise scale with another hint range, and this time let's set the value to 1.5, and it goes from 0 to, let's say, 5, and the step again 0.01. Okay, so what does density scale mean? To make the fog look more realistic, we calculate the density value, I mean this one in the fog function, for each voxel. So different parts of the fog have different densities, which affects the final color. This parameter, density scale, will control something like the overall brightness. As for the noise scale, this parameter will influence the size of the pseudorandom pattern we get using the FBM function, so we can enlarge or shrink that pattern. Let's continue. The 4th uniform parameter would be uniform float speed with another hint range and 1 as the default value, and the range can go from 1 to 5 of 0 to 5 and 0.01, and the purpose of the speed parameter is probably obvious. Higher values mean faster movement of the fog in the set direction. Okay, next, a uniform float, height, fall off. I'll get to that briefly. With a hint range and the initial value 1, and the range, sorry, 1.5, and the hint range would again go from 0 to 5, and the step point 0.1. So what is this? Fall off 2F, sorry. What is this? In games, we usually want the fog to be denser near the ground and thinner at the camera level, which enhances the overall atmosphere. That's precisely what the height fall-off parameter does. The higher the value, the more the fog is compressed toward the ground. Now, uniform float emission, hint range, and starts at 0.5. From 0 to 1 and 0.01 as a step. So the emission parameter will control the level of light emitted by the fog. If we wanted the fog to be invisible and the player to see only the part illuminated by a flashlight, we would set this emission to 0. And finally, uniform vec2 wind. And the initial value vec2, let's say 0 and 1. So what is this? The wind vector determines the direction of the fog's movement. By default, it's set to 0, 1, which corresponds to the z-axis direction. Okay, with that, we have everything ready to improve the fog function, so I guess I can show the fog again. But first, let's enlarge the fog volume so our final effect stands out better. I think we can leave the height of 2 meters and increase the other dimensions to 10 meters. So selecting the fog volume and X 10, Y stays at 2 and Z 10. That's better. Okay, it would also be good to align the fog with the ground, so I'll set the Y position to 1. Transform position Y 1. Now when I rotate the camera, we can see that it's exactly at the 0 position at the ground. Perfect. So let's go back to the shader editor and to the fog function. First, let's set albedo and emission to the fog color. So albedo, fog color, and emission the same. It should turn to green. Yeah, perfect. But we'll want slightly more flexible colors, ideally dependent on the density value for each voxel. So let's improve the emission value. It would be fog color times density times emission. Okay. Very well. The fog now has a nicely toxic color, and we can verify that it reacts to the parameter changes we've made so far, namely fog color and emission. So let's find them here, shader parameters. And now, as I said, fog color. So let's change it to something else. Looks nice. And the emission. Now with them it's more. Now with them it's less. Now it's completely turned off. Okay, let's return the default values. Cool. So with that, albedo and emission are done. And that was the easier part. To set density, we'll use the other parameters and the functions we prepared. So let's start by defining a variable that determines the effect's shift over time. So I'll put it to the start of the script and float. Shift equals time times speed, no times, but plus power of absolute value of the y coordinate of the point and to the power of 1.25. Okay, so notice that what we prepared here is the dependence of the shift on the height of the point, which is actually the y-coordinate of the world position. That gives a more three-dimensional effect because the upper layer of the fog will move slightly faster than the lower ones. And using the power function, we can amplify this effect a bit more. It's not visible yet, but we'll get to that. Next, we'll need the output of the FBM function, which we'll assign to a variable called noise. Since FBM, this one, expects a vector 2 as input, we will use world position without the height, that is the XZ plane. We'll then scale the result with a noise scale parameter and offset it according to the wind direction. So let's do it here. Float noise equals the FBM function applied on, as I said, vector 2 of px and pz multiplied by noise scale, and let's subtract the wind vector multiplied by the shift value. Okay, and finally, we want to apply the height fall-off. Here, a slightly nonlinear curve is useful to make the fall-off smoother. So we've used a negative exponential before, and we'll do the same this time. Like this, float a height mask is exponential of the negative max of p dot y and 0 multiplied by the parameter height falloff. All right, and now we just need to set the new density value. This is simple. We'll multiply noise by height mask and then the density scale parameter. And to prevent the result from exceeding expected values, we'll clamp it to the 0, 1 range using the clamp function. So density instead of 1 would be, as I said, clamping of noise times a height mask times density scale, and the range is 0 and 1. Okay, and we are done. If we look closely at the final effect, we should see the irregular darker layers moving in the set direction and at the set speed. I'm not sure if it's visible on YouTube, but perhaps you can observe these patterns slowly moving in this direction. The plus Z direction. Okay, it might seem a bit subtle at first, but we need to remember that this is precisely how fog works, and Godot deliberately renders it blurred. So the performance remains acceptable even on weaker hardware. Similarly, the fog isn't meant to form distinct shapes. It's meant to create atmosphere in the game, especially if we add other light sources that can interact with the fog. For example, let's add a Spotlight 3D to the scene. Okay, right-clicking the root node again, and let's find Spotlight 3D. And of course, we don't see anything yet, but let's increase the volumetric fog energy parameter of this light. And now, can you see it right here? Yeah, this is our spotlight. And we can see how its cone illuminates the fog. And if I rotate the camera, we can see how the top of the light interacts with the fog right here. While the bottom interacts with the global gray fog, which the main directional light 3D doesn't illuminate. Okay, and if we go back to the fog volume and set the shader's emission parameter to 0, let's do it. Where is it? Resource parameters, emission to 0. We can see that only a light cone is visible and nothing else from the fog. So this is actually pretty useful in some kind of horror games, I guess. And we can rotate such a light. Let's do it right here. And I think we should add the gizmo back, transform gizmos. And now let's rotate. Yeah, this is nice. It could simulate some kind of a lighthouse or anything else that is suitable for a horror game in a dense fog. Okay, yeah, and I guess that's everything for now. Let's just get back and return the, well, sorry, I meant fog volume and emission. Now we have everything right here, and it is still moving in this direction. Thank you very much for watching. I put part 1 in the video title because this tutorial definitely deserves a follow-up. So far, we've only worked with a fog, but it would be interesting to see how the scene looks if we add more objects and a character moving through the fog, maybe even shining a flashlight along the way. So when I make something like that, I'll be happy to share my experience. And of course, I'll add this shader along with the scene to the Godot shader pack, where it will get a new category called fog. You can find the link to this product as usual in the video description. For now, take care, good luck with your projects, and I'll see you in the next video.